Hey guys, Mrs. O'Donnell here. I got a few questions that I wasn't able to respond to directly today about Delta Math, claiming that there weren't any videos. So I thought I would make a quick video for you guys to see kind of how to work through these problems. So the first section that I got a question on was this plot points and graph a line with no table being given. So let's check this out. So first thing we always want to do whenever we get to a new problem that we're reading is to read the directions, right? It says use technology. Okay, so whenever you see a direction that says use technology, what they're really telling you to do is to use a graphing calculator or to use some kind of graphing technology like Desmos, right? Or another free like graphing calculator. Okay, so use technology to find points and then graph the line y equals 5x minus 1 following instructions below. Now, we don't need to use technology. We know how to do this without, and that's what I showed you guys in class. You're certainly welcome to use calculators to help it move a little faster, but let's take a look at how we would do this just by making that input-output table that we talked about in class. All right, so if we're making our input-output table, right, we're making our t-table, and kind of bear with me, guys, I got a new bamboo pad, and it is really sensitive. All right, so just like we talked about in class, whenever you're making an input-output table, you typically want to use some negative values in your inputs, 0, and some positive values. Okay. And then we're just going to take our equation and we're going to follow order of operations. Please excuse my dear Aunt Sally, or PEMDAS, right? Where you do multiplication, division from left to right, and addition, subtraction from left to right. Okay, and let's see here. We're going to go ahead and plug in. So I've got 5x minus 1 is what I'm working with, right? So I got 5. I'm going to plug in my input everywhere I see an x. So I see 5 times negative 2 minus 1, right? 5 times negative 2, that's negative 10. Negative 10 minus 1, well, that gives me negative 11, right? And I'm going to go ahead and plug that right into my table so I can see that coordinate pair, negative 2, negative 11. I could go ahead and plot that point right now. Negative 2, negative 11 would be, I'm going to have to do a little estimating, probably about right there. Okay, and then I'm going to go ahead and do the next problem. 5 times negative 1 minus 1. 5 times negative 1 is negative 5, right? Minus 1 makes negative 6. Okay, and I'm going to go ahead and do my very next problem. 5 times 0 minus 1. Well, 5 times 0 is 0, and 0 minus 1 is negative 1. Right, so I'm going to plug that into my table. I'm going to go ahead and do my next one. 5 times 1 minus 1, right? I grabbed my input right here, plugged it in for x. 5 times 1 is 5, minus 1 gives me 4. Right? And then same thing down here. I'm going to take that 2, I'm going to plug it in for x. 5 times 2 minus 1. 5 times 2 is 10. Minus 1 makes 9. Right? And then I'm going to go ahead and plot. These are all points on my line, right? So I'm going to go ahead and plot them. So I've got negative 2, negative 11, negative 1, negative 6. I'm going to plot that point. 0, negative 1, and 1, 4, and 2, 9. Plot my points. Okay, and then let's see here. Oh, so they want us to do it. Let me see here. I could do this instead of doing it using my work. I could actually do it by, let me see here if I can do it on Delta Math. Let me unplot those points or erase them. And we'll actually do it in the program, right? So 2, negative 11, I can't plot in the program, but I can plot negative 1, -6. I can plot 0, -1. I can plot 1, 4. And I can plot 2, 9. Okay, so it says plot at least 2 points that fit on the axis below. You can click a point to delete it. So next I'm going to click Done Plotting Points because I'm done. It went ahead and placed my ruler for me, right? So just like if you were doing this on paper, at this point you'd grab your ruler, line it up. So now I'm going to graph my line. I'm just drawing it right here from end to end, okay? I don't want to undo. I don't want to change my points. I don't want to erase. It says click and drag. Make sure that you drag the graph from end to end so you get to both sides. Make sure you may draw your graph all at once or piece by piece. Okay, good. We did all of that. I think we're done. Let's go ahead and submit our answer. Yes, oh, yep, submit. And all my work is still on the page and life is good, okay? So really the key here for graphing was making that input-output table. All right, let's see here. Let's just check and see if the other problems are similar. Okay, so we talked about 3 different problem types in class, right? Last year you learned y equals mx plus b, right? Where m is your slope and b is your y-intercept, right? And then we just learned standard form, which is ax plus by equals c, right? We just learned standard form, and we know slope-intercept form is best used when you have slope and a y-intercept. Standard form, the key features that are easy to find from standard form are the x and y intercepts. And then our last form is y minus y1 equals m times x minus x1, which is called point slope form. Okay, and that actually looks like pretty similar to what they're giving us here if I add 4 to both sides of my equal sign, right? So y plus 4 equals -1/4 times x plus 1. And now it's in point slope form. So for point slope form, the easiest way to graph your line is to identify the point that's in your equation, right? So my x coordinate is going to be -1 and my y coordinate is going to be -4. Okay, and I know that because here I see a plus sign, but in my equation, in my general form, I have a minus sign. So I know that when I pull that 4 out, I have to have, it has to be the opposite sign, right? So my point is at -1, -4, and I know my slope is at -1/4. So if I wanted to go ahead and start plotting points, I could plot a point at -1, -4, and I would go down 1 and over 1, 2, 3, 4, using my rise over my run, right? Or I could do some backwards thinking and go up 1 and back 1, 2, 3, 4. Okay, so I'm done plotting points. I really only needed 2 points to make a unique line. Now I'm going to go ahead and draw my line. Whoops, my computer it's not like this. All right, so I've got my line drawn, and I'm going to go ahead and submit. Yes, submit, and Delta Math liked it. Okay, so that's how you want to plot points and graph a line without a table. You can either make a table or you can recognize the key features from our different forms, and you can use that to help you graph more quickly. All right. Let's see here. The other question that I got that I wanted to include in this video, which I only have a couple minutes left, plot points and graph the lines by solving for y is the very next one, right? So let's see here. it looks like what they're suggesting that you do is you solve for y, so you're putting it in slope-intercept form. And I think that's a great strategy, right? So if I have 6y plus 4x equals negative 18, right? And I'm solving it for y, I'm going to use reverse order of operations, or SADMEP, to help get rid of everything that's attached to y, or try and isolate that variable, right? So first thing I'm going to get rid of is this added term of 4x, and I'm going to do that by doing the opposite, which is subtracting. If I do it to one side of the equal sign, I must do it to both sides of the equal sign, right? So I've got 6y. I know 4x minus 4x is 0, and 6y plus 0 is just 6y. And I'm left with negative 4x minus 18, or plus a negative 18. And then I'm still trying to get y by itself, so I'm going to divide both sides of the equal sign by 6. If I do it to one side of the equal sign, I have to do it to the whole other side. 6 divided by 6 gives me 1y, which is what I wanted. And then I'm left with negative 6x minus 18 over 6. And I can reduce those. So I have negative 2/3 x minus 3. And now I see, okay, it's in slope-intercept form. That's the easiest form to graph in, right? Because the shortcut way, you put a dot on your y-intercept, you plot your point on your y-intercept, and then you follow your slope, your rise and run. You go down 2 over 3. Plot a point. Down 2 over 3. Plot a point. Down 2 over 3. Plot a point. You could do some backwards thinking as well if you are comfortable with that. Okay, let's see. I'm done plotting points. Now I want to grab my ruler and graph. Oh no! Undo. Let me try that again. Grab my ruler. It's hard to do with the mouse pad, huh? Grab the ruler and plot my line. Oh no! I almost had it until the end. Oh, all right, one more time. Last time. I'm going to get it. All right, I'm taking a little break. Taking a little break in the middle so I don't have to start over again. All right, there we go. I finally got my line plotted. Go ahead and submit the answer. And they like it. Okay, so that's how you solve for y, right? You're following that inverse order of operations to isolate the variable. Okay, if you have any other questions, please don't hesitate to reach out. Thanks so much, and I'll see you guys tomorrow or later this week or next week, depending on when your next class is. Okay, good night.